x to be -1 and x to be -3. However, because we do this step here, and what we're actually doing is trying to figure out what a and b are, it's okay for us to choose x to be whatever we want it to be. Is that correct?
For B?
Like again?
Yeah. Alright. Yes.
There you go.
Yeah.
That's correct. And yes, it's
Alright.
perfectly fine. Alright. Hey, Fred.
Just all rubber bands, classic.
Ah. They're one of those bands which is really famous and influential, but I cannot stand their music.
I'm just guessing you don't like Leland Helm's voice.
I think it's probably it. I also think it's because they do a version of The Night They Drove Old Dixie Down.
It's good.
I actually like the version sung by the lady. There's another version
I've
that's
heard
much
that,
better.
yeah. I like that.
Oh.
I like
Oh.
that. I can't
Alright,
stand
so-
it.
Okay, anyway. Perfect. Okay.
So, now we have to,
Do anything.
so, I just do it up here.
Pretty sure you said that. In this era to people. So.
Oh shoot, I have to, I might have
It's alright, it's alright. Just keep going. Because that's always fixable at the end. Also, too, it's since we know what the original problem was to start with, if you want to just put a squiggly line there, that's
Okay.
always fine by me.
What do you mean?
So, like, what I mean, everybody with the squiggly line is, at this point, you can just do
Okay,
that.
alright.
That's fine. That's not a big deal. Oh, sorry. That's fine. Alright. Alright, excellent. Perfect. Alright. Everyone see how that worked out? Okay. The, yeah. The important thing here, everybody, is what the finalized answer over here is. You don't need to necessarily rewrite this beginning part every single time you do these things. In fact, don't, I do it up here on the board. On your own papers or on your own, on a test or a quiz, I'm not actually going to expect you to do that. I am expecting you to fill in what A and B are and write out these fractions, but that's as far as you need to go. We don't need to keep saying this over and over and over and over again. Okay, that's the sort of nitpicky thing that we don't need to worry about too much. All right, but yeah, this is absolutely perfect. And notice the other big thing too, went ahead and simplified these down as well. So which is always the good thing to do, okay, when you're doing these problems. Any questions there? All right, this next one will be probably the trickiest one we'll see here, okay? So we'll go ahead, move to the next page. This one right here that has the repeating factor in it. Who wants to give this one a go?
Who hasn't gone yet? Rhodes. Brendan's got this one.
Yeah. Brendan's good. All right.
Chad, did you go?
Any volunteers? Don't let me pick. I hate doing that. All right.
Would you make 2 0 though? That's like
Okay.
would you make that 0 as well as a 1?
Right. Basically, what's going to happen here, everybody? How about this? Okay, I'll be nice and I'll do this one, just so you get the idea here. Okay. And I won't call people. Basically, because we've got this x squared here, Okay? That means ultimately when we set this thing up, we'll have a letter that we can't immediately solve for. So we solve for the other two, and then once we have those answers, we're able to fill in the third one. Okay? So when I'm dividing this out here, the way I would write this is A. Now, the opposite denominators for A are x squared and x minus 10. However, the denominator for A is x, so this is that case where I'm saying you do have to kind of adjust when doing that kind of opposite denominator trick. Instead of putting x squared, you would just put x, because that x and the x squared cancel out, but then we do put the full x minus 10. Okay. B is just going to be x minus 10. We don't have to worry about the other x because, again, it would be canceled out with the whole x squared thing. Okay? And then C gets the x squared like so. Okay? Everyone catch how that works there? So with these ones, when there is a repeating factor, the whole trick of just choosing the denominators that aren't the one that you're under is not quite as reliable. You have to kind of figure out, you still have to think of what exactly is going on when you do that sort of
Wait, is that
picking.
a of x? Why is it not x squared? Because if
Because basically, remember, we're going to times a by x squared times x minus 10, and the x cancels out one of the x squares. That's why it's just an x here. That's also why there's no x over here by b,
okay.
because the x squared technically cancels out both. Okay, which is why, just why I was explaining that trick I showed you, the first two, doesn't quite work as well here.
Okay.
Okay, and that's sort of the whole. That's the problem with these repeating ones. Okay. Otherwise, we got this set up nicely. It's still equal to 12. Okay, and we just go ahead and play the picking game again. What's the easiest one to pick from right off the bat?
0.
0. If I pick x to be 0, I'll get rid of a and c. So we'll do that. When x is 0, we're going to have 12 equals b times minus 10. That gives me that b then is equal to 12 over negative 10. What does that reduce down to?
Negative 6 over 5.
Negative 6/5. Okay, good. Alright. Next one. Alright, how about
10.
10? Okay. Why 10?
Give us an A and B.
Gets rid of a and b, right? Leaving with just c.
It's
So that gives me 12 equals c times 10 squared. That gives me 12 is equal to 100c. Oh boy. And c then is equal to 12 100ths. Okay? That's not a very fun number to deal with, but there you have it. Okay? 12 100ths. Actually, this isn't so bad. This one over here is worse than this one, actually. All right. Now, what's the problem we hit here? Okay. Is there anything else I can pick for x that lets me solve for a? Nope. So what do we got to do?
Plug in B and C.
Okay, we're going to plug in what b and c are into this problem, and then pick any x we want to. Okay. What's the easiest x for us to pick?
1.
Okay. 10 doesn't work. We're already 10 always cancels stuff out. We can't do 10.
Right.
Can't do 0.
11.
0 also cancels stuff out.
1.
You say 11. 1 is actually usually the easiest number. And I would choose 1 as well. Okay. 1 is usually, generally speaking, in math. Okay. A little kind of a trick that always happens. If you're gonna pick any numbers, or if something interesting is gonna happen, it's generally gonna happen between -1 and 1. And so when you're left with a problem to pick numbers with, usually the easiest numbers, the best numbers to pick when you're starting off a problem are 0 first, then 1, then -1. Okay? So we already picked 0. Next easiest thing is always 1. So we'll pick 1 in this case. Okay? So when x equals 1, what happens? Okay, this one's going to be a little bit more involved. So it's going to be 12 is equal to a times 1 times 1 minus 10, which is 9. Negative 9, excuse me. Okay. Plus b times, it'll become -9. Plus c times 1, correct? Now, we already know what b and c are, so let's go ahead and make those substitutions. This one right here, B is -6/5. I'm going to go ahead and make it a fraction, decimal instead. Okay, so I think that will make our lives a little easier when we work this out. -6/5 as a decimal. What's that going to be?
1.2.
1.2.
1.2.
So -1.2. Okay. Okay. And C is 12/100ths. What does that become when I turn it to a decimal? 0.12. Okay. So 0.12 basically. All right. So that's what we've got right there. Now it's just a matter of cleaning this all up. So we've got 12 equals -9a, okay, plus 1.2 times 9 is something I don't know off the top of my head. So calculators were actually, should be 10.8 actually, take that back. That is something I do know off the top of my head. Okay, plus 0.12, okay, so that gives me 12 equals -9a plus, that's 0.12, not 12, excuse me, plus 11, no, 10.92 is what it comes out to be, okay? Because that's 0.12, not yeah. All right, but that makes life easy in the end. We just subtract 10.92 from both sides. By the way, everybody, this is why we use calculators. Okay. So at this point here, I'm going to take over with the calculator because I'm not trusting my math at this point, my mental math. Okay, so it gives me 1.08 equals -9 a. So divide that by -9. And that gives me -0.12 equals a. Okay, and we know that was 12/100ths. Okay, so we wanted to convert that back, we can. Okay. All right. So we got A, B, and C now. Now to finish these things out, if we're doing it properly, it's going to be -12 over 100x, okay? That's the A one, plus B was what, -6/5? -6 over 5x squared, okay? Plus C was 12 over 100. It'd be 12 over 100x minus 1,000, okay? Would be what we got there, okay? As our final answer. Yeah?
When you simplify the 12/100s to like 3/25ths and
Yeah, you could do it that way if you wanted to, absolutely. Yeah, anytime you want to. If you want to simplify something, go for it. 3/25ths works just as well, okay? Everyone got this so far though? That's interesting, I didn't realize 3/25ths is 0.12. Huh. Usually it doesn't work out that nicely, but okay. All right. Guess that happens. All right, good. So, that's how those cleaned up with. All right, now the next one's for homework that we had from the night before, and kind of reviewing these things here, okay? I believe I gave you what, 63, 60, what were the numbers? Anybody have them?
65.
70.
63, 65, and 70.
Wait, this is tonight.
Okay.
What? What?
63, 65, and 70. Okay, so with these here now, what we're asking to do is we want to go ahead and do the partial fraction decomposition of these. And then we want to check our results algebraically by actually adding the fractions together, okay? And graphically to see if we actually get the same answers, okay, when we graph these things. That is, if I were to pop these into a graph on a calculator, if it gives me just one picture for both my